Yes, yes. Now, the last class we discussed about permutations when in the non-repeated case. All these are linear
Yes.
permutations in the case of non-repeated case. So far, what we discussed. Now, here a new thing here. Permutations when the repetitions are allowed. So first, while you're arranging any objects or anything linearly, in the case of repetitions are allowed, assume that the elements are available many number of times. So if you use A1, again A1 is available. If you use A2, again A2 is available. If you use A3, again A3 is also available. So number of arrangements by taking two at a time, let us suppose. There are three elements in the set here. I want to arrange by taking two at a time. These are the two places you're having. These are the two places and three elements. Yes. Two places and three elements. Now, first place can be filled by any one of these three in three ways. For suppose, even if you use A1, again A1 is available. Again A1 is available. So the second place is also having three sources. Okay. Now, so 3 into 3, there's nothing but 3 square. Note that here the repetitions are allowed here. Here the repetitions are allowed. Remember, the repetitions are allowed here. Yes, no. Similarly, if you go for say set S contains n number of elements. Number of arrangements for taking or at a time if you take, first place has n choices, right? Second place also having n choices. If you use one A1, again A1 is available here. If you use A2, again A2 is available here. First place has n choices, second place has n choices, and so on. Rth place also having n choices. So n into so on r times is nothing but n to the power of r. This is what we get. It's called permutations when distributions are allowed. This is what we get. Okay. So what is the application of, what is the use of these permutations when repetitions are allowed? What is the use of these permutations when repetitions are allowed? So let me explain. Yes. Now, we make use of these permutations when repetitions are allowed, especially while we're discussing the number of functions from A to B. I'll explain. Yes, here. Now, if you see here, number of functions from A to B. Yes, here. Set A contains, let us suppose, R elements, A1, A2, and so on, R elements, and set B contains N elements. Okay. Bn contains. Set A contains R number of elements, and set B contains N number of elements. All of you know, number of functions that can be mapped from this one, from A to B. Number of functions that can be mapped, number of functions from A to B. How many number of functions from A to B is possible? This is what we have here. Yes, let me explain. So note that repetitions are allowed. All of you know what is the definition of a function. A relation is said to be a function. A relation is said to be a function if each and every element in the domain, has unique image. That means all elements in the domain should have an image, and that should be unique image. And here also if you take, right, how many such functions are available by using this one? Yes. R places are here. R, what are the number of elements in the domain? You take A1 because you are mapping from A to B. So take all the elements in the domain as places. All the elements in the codomain as choice. First element has how many choices? N choices, no problem. Has N choices, no problem. That means let us suppose A1 is mapped to B1. Yes. Even though A1 is mapped to B1, A2 can also be mapped to B1. Because that is available for each and every element. Because multiple mappings, no problem. You can have. That means the images can be shared, no problem. But the elements should not have more than one image. So what do you mean by function? Each and every element in the domain has one and only one image, then it is called as a function. Then that relation is called as a function. So A1 has n choices. Even though A1 is mapped to B1, A2 can also be mapped to B1. A2 also having the choice B1 here. This is what we have. So similarly here also, A1 has n choices. A2 also having n choices and so on. Here also is having n choices, you're having like this. So applying fundamental principle, if we take, right, applying the fundamental principle, that is equal to n into n, so on, r times, it is nothing but how much you get in n of r. So n is nothing but number of elements in codomain, and r is nothing but number of elements in A. Got the formula that decreases number of functions from A to B. So it's a wonderful result you can prove by using permutations when definitions are allowed here. Yes, here. A1 has n choices. Even A1 is mapped to B1. A2 is also having the choice of B1. Like that you're having. So repetitions in such a way that imagine that the objects are repeated again and again. For example, when you went to a shop, the models of shirts are displayed on the display. The models of the shirts are displayed on the shelf. No problem. So what happens is if you select one shirt, definitely the shirt is replaced by on the same place. That means model will be same. But again, if you purchase any shirt of that model, again that shirt will be replaced. Similarly here also, when you use B1, again B1 is available. When you use B2, again B2 is available. Imagine that while you're doing the problems related to the repetitions are allowed, objects are repeating again and again. B1, if you map to B1, again B1 is available to A2. Again B1 is available to A3 and so on. Like this you have it. And similarly here also, number of functions from A to B, you take the domain elements as choices. A1 has n choices. A2 also having n choices. They are also having n choices. N into n into so on r times is nothing but 10 to the power of r. N is nothing but number of elements in codomain. R is nothing but number of elements in A. This is nothing but n of B power n of A. This is how we can prove very easily. This is what we have. Number of functions from A to B. So, but when you go for a number of one functions, there we use the permutations when repetitions are not allowed here. N of BP, n of A. There we use non-repeated case. To calculate the number of functions from A to B, we use this one. Repetitions are allowed. Such problems you can do. Okay.